because this matrix is having 3 rows, but it is having how many columns? 2 columns. So it is not a square matrix. In essence, what I'm saying is this: a square matrix is a matrix that is having what? Same number of rows as the number of columns. You understand it? Do you have anything to pen down? If there is nothing to pen down, let's proceed. We are still looking at examples of what? Special matrices. And we said the first one is known as what? A square matrix. Let's go to number 2. Diagonal matrix. Diagonal matrix. Diagonal matrix. Look at it. 1 is a square matrix. 2 diagonal. Are we there? Diagonal matrix. Before I pen down anything, let's get something. A diagonal matrix must be a square matrix. Am I communicating? So it goes to show that a diagonal matrix is like a sub-example, a semi-example of a square matrix. Alright? Let's just get that here. Keep it somewhere. We'll make use of it as time progresses. Okay, diagonal matrix, let's just jot down something so that when you are reading on your own, you'll be able to say 1 or 2. Okay, we have this. This is a square matrix. We are looking at diagonal matrix. This is a square matrix. This is a square matrix. This is a square matrix. This is what I'm saying here. With all elements 0. With all elements 0. We know what elements are. The numbers found inside the array. They are known as the elements. With all elements 0, except, that is the condition now, except those on the leading diagonal. This is a square matrix in which all elements are what? 0, except those on the leading diagonal. The question is, Mr. Victor, what is a leading diagonal? Because without understanding properly what a leading diagonal is, you won't be able to have a proper understanding of what a diagonal matrix is. So we'll do it this way. Follow me up here. Follow me up here. We are already aware of the fact that a matrix must be represented with what? A bracket. Right? And we have something like, let me put it, 2, 4, 1, 3, 5, 6, 7, 8, and 9. What is the order of this matrix? 3 by 3 matrix. Good. But we are looking at diagonal matrix. Follow me up here again. Look at this. What is the name of this shape? Let me put it like this so that my drawing won't confuse you. What? This is a rectangle. So if for a rectangle, you can see that the 2 opposite sides are always equal. Here is equals to here. Now look up. If I decide to put a line here to divide this shape like this line is called what? A diagonal line. So a diagonal can come either from here to here or from here to here. But if Mr. Victor is, if I'm moving from here, I am moving. Definitely, you don't expect me to move from here. I should be moving this way. It is always easier to move from right to left than moving from left to right. If I'm standing here illustrating or teaching you, you see that most times, if I want to move, it is easier for me to move this way than for me to move this way, my right hand side. If I'm this way, Mr. Victor, yes, move. I'm moving this way. Those following me behind. So what Mr. Victor is doing is, I am leading. I am leading the way. Now when we're writing our element, Mr. Victor didn't write it anti-clockwise. You saw me writing it this way. So it's always from here. So the leading diagonal is always from here. Downward like this. And not from here. So with that now, I want to say something. Mr. Victor said, a diagonal word matrix is a matrix that all the elements are what? 0. Except the what? The leading diagonal. That means here, this is the leading diagonal. 0, 0 here, 0 here, 0, 0 here. Where again? Here, 8 here, 0 here. So look at the leading diagonal. Look at it this way. Look at it this way. You can see that this is also a diagonal, but all the elements here are not 0 because our concern is with the leading diagonal. So don't come here and say, Mr. Victor, the leading diagonal, all the elements are not an ordinary number. It is because this is not a leading diagonal. For it to lead, you have to start from the head, which is here. So this is an example of a square matrix. Every other element are 0, except the element found on this diagonal line. Not just the diagonal, but the elements found on the leading diagonal. So when you have something like this, this is what? A good example of a diagonal matrix. Am I communicating?
Yes,
if you have anything to pen down, let's proceed. I've given the definition of a leading diagonal. If you want to give further explanation with the help of this, you can do that. If not, let's continue. Number 3, we are looking at special matrices. We started by saying number 1 is called what? A square matrix. A square matrix is a kind of matrix that is having what? Same number of rows as the column. We went further to look at number 2, diagonal matrix. We said a diagonal matrix is a matrix that what? Every other element of that matrix is what? 0, except the what? Element found where? On the leading diagonal. Number 3, unit, U-N-I-T, unit matrix. Unit matrix. Unit matrix, U-N-I-T. This is a diagonal matrix, meaning a unit matrix must be a diagonal matrix. Over there, while you're standing, we have empty seats here. Come over here. We have both in front here, over there. This is a diagonal matrix in which the elements on the leading diagonal are all unity. U-N-I-T-Y. This is a diagonal matrix in which the elements on the leading diagonal are all unity. U-N-I-T-Y. We didn't get that? No. Good. This is a what? A diagonal matrix in which all the elements on the leading diagonal are unity. The word unity means similar. Same elements. If I come here and Mr. Victor decides to change this 2 here to 1, change this one here to 1, change this 9 to 1, this is an example of a unit matrix. Why? I said all the elements on the leading diagonal are all unity. They are all the same. 1, 1, 1, 1. So that's why it's called unit. Unit means 1. A unit matrix. Can I move on? Good. Number 4. A null. N-U-double-L. N-U-double-L. Null matrix. Simply known as zero matrix. Null means void, empty, 0. A null matrix, also known as what? Zero matrix. Let's see what we have there. This is 1, O-N-E. This is 1, this is a matrix. This is 1 whose elements are all 0. This is a matrix in which all its elements are what? 0. It is known as what? A null matrix or 0 matrix. All the elements, you already know what element of a matrix are. Meaning, if I change all the numbers here, this one too give me 0. I change this one to 0. I change this one to 0. You can see that this is an example of what? A null matrix. Reason being that all the elements here are what? 0, 0, 0. That is a null matrix. Remember, I started by telling you, you might not be asked types of matrices in exam. But here is a stepping stone a foundation into understanding properly what is ahead of us, the mathematical challenge or challenges ahead of us. Without getting this introductory aspect very well, we have challenge when we encounter the solving aspect. That is why you see me taking the pain to start from introduction to metrics. Alright, let's move. Addition and subtraction of matrices. We are now entering into the game. Addition and subtraction of matrices. Up here, we have what? Addition and subtraction of what? Of matrices. Alright. To be added or subtracted, we are writing, let's get down something. To be added or subtracted, comma, to be added or subtracted, two matrices, there is a condition attached. Let's see the condition here. Two matrices must be of the same, you can underline the word, the same order. Must be of what? The same order. Full stop. So for us to add two matrices or subtract two matrices, the both matrices must be what? Of same order. That is, the first matrix must be, for instance, 2 by 3 matrix. The second matrix must as well be what? A 2 by 3 matrix. Meaning if you are having one matrix to be like a 2 by 3 matrix and the second one is a 3 by 3 matrix, it is, let me say, impossible to add or subtract the two matrices. But when you have a matrix A as a 3 by 3 matrix, on the other hand, you have matrix B as a 3 by 3 matrix, it is very, very possible to do what? To add or subtract the two matrices. Reason being that they have same order. So if you come across a challenge, a mathematical problem that is asking you to add or subtract 2 or 3 matrices or more, as the case may be, the first thing that is expected of you is to look at the order of the first matrix. Make sure it is equal, it is equivalent to what the order of the second matrix. That should be your first step. Once you've achieved that, you can then proceed. So you can start something that you're only wasting your time. It doesn't have an end. Or something that is not possible. But because you failed to do the first step, you're only wasting your time. This is exam. Time is going. You are struggling to get the answer. Struggling, whereas it is not possible. It will not work. You have a matrix 2 by 3. You have this other one 3 by 2. 3 days for this one, 3 days for this other one. Good. But it's not a yardstick for you to say, okay, I can add it. You have this matrix like this, 3 by 2. You have the second matrix, 2 by 3. So, no be 2 day here, no be 2 day here. No be 3 day here, no be 3 day here. That is not what we are saying. This one is having 3 rows and 2 columns. This one is having 2 rows and 3 columns. So you can see that the number of row here is not equal to the number of row in the second matrix. The number of column for the first matrix is not equal to the number of column with respect to the second matrix. As such, Mr. Victor is telling you, you can't add or subtract these two matrices. Having said that, let's proceed. Okay, the sum, we are writing SUM. The sum or difference, that's addition and subtraction. The sum or difference is then determined by adding. The sum or difference is then determined by adding or subtracting the corresponding elements. The sum is then added or the difference subtracted by what? matching it with what? The corresponding elements. Let's look at example 1 here. Let's see the first example here. Example, you have this. You have this matrix here. This matrix could be a 2 by 2 matrix or a 2 by 3 matrix. You have 2, 4, 5, 6, 7, 8. Close it. Plus, let's call this matrix A. Another matrix on this other hand, having 1, 2, 3, minus 4, 5, and 3 here. We close it. Let's call this matrix B. Here comes the question. Divine. Divine. Now you are changing. I'm just looking at you with one eye. You come late often now. Look for a place to sit down. Over there, both of you. That friendship is not yielding anything. The both of you, I'm telling you. You be coming late often. When you started, it was not like that. Now we have this here. Asking you to look for matrix A plus B. Look for matrix A minus B. Let's use this as example. The first thing we need to do is to look at the board very well. Matrix A, what is the order of this matrix? What? 2 by 3 matrix. What is the order of this matrix? 2 by 3, that is the first. So our problem is half solved. For the fact that both matrices are of equal order, it means we can then proceed into adding or subtracting, as the case may be here. I started by saying all you need to do, this one is very, very simple here. The individual elements have to do what? Add up based on their location or address. This one, this is A11. Am I correct? And here is also what? A11. Those of you that said you don't know who got this. This is the first row, 1. This is the second column, 2. This is the first row, 1. This is the third column, 3. This is the first row, 1. This is the second column, 2. This is the first row, 1. This is the third column, 3. This is the second row, 2. This is the first column, 1. This is the second row, 2. This is the second column, 2. This is the what? Second row, that is second. This is the third column, 3. Let's do it here. For here, this is the second row, 2. This is the first column, 1. The second row, the second column, 2, 2. The second row, 2. The third column, 3. Who don't understand it? Who don't understand? None. You can then proceed. Okay. We said you have to what? Add the corresponding element. When something is corresponding, what does it mean? A11 to A11, A12 to A12, A13 to A13, A21 to A21, A22 to A22, A23 to what? Okay, B23 the other side there. So here we have it this way here. Let's go. This to this is going to give us, this is what we are having here. This and this, that is 2 plus 1, because I'm looking at addition. I'm done with this. Into this now, 22 plus 2, 22 plus 2. Next, I'm having this.
You say what?
What?
4 plus 2.
Oh, 4 rather. The numbering, sorry. 4 plus 2, and here we have 5 here and 3 this side. So that is 5 plus 3 there. I'm done there. I come over here. This is 8 here. 6 here. That is for 21. Plus minus 4. Take note of this sign. Plus minus 4. And we have 7 here. That happens to be 822. That is 7 plus what? 5 here. And here we have 8 here. Plus 3 here. Close your bracket. Calculator for what?